hari ini kita belajar chemistry. Mari kita start discussion-nya lah. Jadi ada apa-apa cerita yang orang tak paham? Cetuan. Apa tajuk dia sudah? Atoms and Molecules. Ya. Tapi kan atoms and molecules ni ada benda kita paham tak? Itu apa itu proton, neutron dan elektron? Sebenarnya relative mass dan charge bagi proton, neutron dan elektron.
So basically my friend asked just now about proton, neutrons and electrons. Actually proton, neutron and electron is a subatomic particle present in an atom, the smallest thing that can participate in a chemical reaction, as you can see over here.
Uy, terbalik itu.
Oh no. As you can see, protons will be represented with the symbol of P. Its charge will be positive 1. Relative mass in units of AMU will be 1.007. Its approximate relative mass in units of AMU will be 1.0. So, neutrons will be represented with the symbol of N. As you can see right here, it was 0 written, so neutron is neutral with no charge. Neutrons' relative mass in units of AMU will be 1.009. Approximate relative mass in units of AMU will be 1.0. So basically, as you can see, protons and neutrons has the same mass, 1.0. Electrons, on the other hand, represented with the symbol of E, its charge will be negative 1. So guys, remember, electron is negatively charged. Its relative mass in units of AMU would be 0.0005486. So the mass is very small.
Proton number, nuclear number, dan isotope.
Proton number in chemistry defines as the number of the proton in the nucleus of an atom. Get it? Okay, now we go to the nuclear number. Nuclear number. What is nuclear number? Okay, actually nuclear number is the total of proton number and nuclear number in the nucleus of an atom. Got it? So basically it's proton number plus neutron number and we get the nuclear number. Get it? Okay, now we go to the isotopes. What is isotope? Isotope actually are the atom that have same number of proton but different number of neutron. So basically, the isotope share the same chemical properties but different physical quantities. Got it?
What about relative atomic mass and relative molecular mass? What is the scale used?
Relative atomic mass, relative molecular mass, scale. So basically, International Union of Pure and Applied Chemistry (IUPAC) has adopted a scale of isotope carbon-12 to be used as a scale. So basically, every measurement we make will be related to the carbon-12 isotope. The relative atomic mass, or RAM to be short, will be counted based on the isotope of carbon-12, as you can see right here.
Oh, tidak terbalik lagi.
Tidak terbalik.
Okay.
Not upside down. So as you can see right here, the RAM, or relative atomic mass, we can calculate it with dividing the mass to one atom of the element. But to make it simple, the RAM is always equal to the nuclear number. For example, oxygen, the nuclear number is 16. So on the other hand, the RAM will be 16 as well. That is how you calculate the relative atomic mass.
What about isotopic notation and how do I write it?
Isotopic notation and how do you write it? Simple. I'm gonna take this one. So, let's see. Gonna represent the nuclear number of an element, of the atom. Well, on the other hand, on the downside, B, proton number will be written signaling how much proton that is present in that atom.
So what about this question? What is relative abundance of isotope mass spectrum? What kind of things that? So how to find the isotopic abundance? We will use this formula. So we will use this formula. Isotopic abundance is equal to number of atoms for a given isotope over total number of atoms for all isotopes of the element times 100. So now the mass spectrum is totally look like this.
Let me see.
Calculate the average atomic mass of boron 10 and boron 11 with its isotopes abundance of 80% and 20% respectively. So this is actually mass spectrum. Okay. To find the average atomic mass, we need to use the formula Ki-Miki. What is Ki-Miki represent about? Okay. Ampai di meja. So Ki-Miki. Ki is represent to the abundance of isotope abundance, which mean this here, this and this. So the Mi represent relative isotope mass, which is this and this. So boron 10, the Ki is 80%, I'm sorry, and Mi is 10. Boron 11, 20, its Ki is 20% and Mi is 11. So to solve this, we need to use the formula. So Ki 80% times its Mi 10 plus 20 times 11 over the total of Ki 80% plus 20%. So 20 plus 80. So 80 times 10 equal to 800 plus 20 times 11 is 202. 20 over 100. So 800 plus 220, it's equal 1020 over 100. So its average match is 1, 2, 3. Its average match is 1.02 AMU. You must what do you call that? You must have the unit. If you not, it's wrong.